Normal variable, model versus actual. Session prerequisites. Browse to our earlier material on normal variables. In preparation, please have the spreadsheet open on your computer and follow along. Maximum benefit guaranteed. Learning objective. How does normality emerge within a dataset?
Are you making sense out of this noise?
Yes, Lisa. These are monthly returns for two stocks in pharma. They go up and down across the months.
Let me guess. When in doubt, histogram?
That's my next step.
The one on the top looks more normal to me.
You're correct, but can you tell me why?
I'm guessing by those thingies on the left?
Your guess may be right. Welcome back to Statistics for Business 1. I am Shankar.
And I'm Liza, short for Lively Young Stats Advisor.
And Brainy. We are examining two stocks in the Indian pharma sector. Much thanks to CMIE for letting us access their prowess database. By now, you know what the density of a continuous variable is used for.
It helps us work out probabilities.
Right. Here's the histogram for the first pharma stock with the density superimposed on it. Suppose we assume that the monthly returns for pharma 1 are normally distributed. Its parameters mu and sigma are derived from the actual monthly returns. We will lay this density over the previous picture. So you agree, Lisa, that the normal approximation is good? Normal distributions are popular because of the way they contain data. We covered this in our last segment, and this picture is what I'm talking about. Notice that these are very special limits for containments.
God, I love symmetry.
For a normal random variable x, we are faced with more general questions. Here is a list.
What's the probability that x lies between two values a and b? We write this as probability of a less than equal to x less than equal to b. Given a percentile, what's the corresponding value of x? Test if a variable is normal.
For the rest of our discussions, x is the normal variable that approximates monthly returns of pharma 1. Now x has parameters mu given by 0.02 or 2% rate of return, that is, and sigma is equal to 0.108 or 10.8%.
So pharma 2 is left as an exercise? Brilliant.
You bet. Let's take up question 1 with concrete values. We ask, what's the probability that the monthly returns of pharma 1 are between 5% and 15%? Here's my take on tackling such questions. Step number 1, quickly put your pens to paper and sketch a normal curve. Don't be too worried if you don't do it absolutely perfectly. So I draw my x-axis and I draw where the mean goes, and I will try drawing a normal curve. I'm not that worried. Step number 2, indicate the mean and standard deviation. Usually you're supplied at least one of these two pieces of information. In this example, we have both the pieces. So I have mu as 0.02, which is 2%, and I have sigma given by 0.108 or 10.8%. Step number 3, translate what is asked into either a region in this picture or a point if it is a percentile. In our case, we know the mean is 0.02 or 2%. This means the region we are interested in, 5 to 15%, hangs to the right. So here I have 5% to 15% hanging to the right, and I'm going to shade it. Here is a neater picture, but don't worry about being exact. Our question becomes, how much is this area between 0.05 and 0.15? This area is the difference of two cumulative probabilities. We have one cumulative probability of everything up to 0.15 minus everything up to 0.05.